Okay, so looking at number 2, again, I like to try to look at these kind of like yesterday and try to think of them as out of context as I possibly can. In other words, I just want to think about number 2. Like, what if number 2 was on a quiz or a test? What would you probably do? And I'm thinking you would probably say, let's just try to do a direct evaluation kind of an idea and see what happens. You can't really plug in infinity, but if you think about the top, x approaching infinity, same thing with the x's in the bottom, what would happen? What do you see happening here? Infinity over infinity. And so prior to this, if you would have seen something like that, you probably would have said, and I think justifiably said, I don't know what to do with that. Maybe you would have said DNE, something like that. That would have seemed like a pretty reasonable answer. But now we know that if you see a form like this, infinity over infinity, that should trigger us to use L'Hopital's rule. Yeah. So here's the notation I'd want you guys to use. And it's right here, little arrow with an LH, which stands for L'Hopital's rule. And with L'Hopital's rule, what we do is we differentiate the top and we differentiate the bottom. So the derivative of the top is 2x. The derivative of the bottom would be what?
E to the x plus 1.
Yep, that's right. And so once we've done that, then we retry the limit again. So here, if we think about x going to infinity in the top and the bottom, what do we get?
Infinity over infinity.
This is a little different than the first one, right? Because the first one we did L'Hopital's rule and it all worked out well. Here, we get another one of those indeterminate forms again, infinity over infinity. So that doesn't mean we made a mistake. It doesn't mean that there's no answer. It means that we just keep going, right? Indeterminate means we don't know the answer yet, but with some continued efforts, maybe we will. So guys, this is really important. This is one of the conditions for L'Hopital's rule, infinity over infinity. So if you see that, you have the okay to proceed. If you don't see that, then you're going to need to make a judgment at that point, right? So we can proceed with L'Hopital's rule. So I will do it again. L'Hopital's rule, limit as x goes to infinity. This time the top is 2 and the denominator is e to the x. So the fact that the top is 2 tells me that we're going to be done here, right? Because there's no way that the 2 could become a 0 or an infinity. And so I know it's going to be 2 over something, which tells me that I will be done here in just a second. So as x gets really huge, the denominator does what? It gets really huge as well. So if the top is held constant at 2, the denominator is getting gigantic, the whole fraction is going towards 0. Yeah. So the final answer here would be equals 0. So I want to encourage you guys to do something really quick. We can confirm this with a calculator. If you'll get your calculators out, please look at the original function, which is right here, x squared over e to the x plus x, and graph that and look at the right hand end behavior. See if it looks like it's getting closer and closer to the x-axis. Those are ones that other kids just left here. It's almost like they just left $120 just like sitting around. You can use one of mine, but not one of theirs. That's definitely not one. I don't think that's yours. Get that on there. It's on our video now. Okay, so let's take a look at number 3. To make this make a little more sense, the t in the bottom really should be an x.
Oh, okay, that makes more sense.
Sorry, yeah.
You guys were all very I was like, what? There's 2 variants.
So it just becomes 0 over 0 then.
Should be x. Yeah, there we go.
That makes more sense. Okay.
Together, let's make sure we get the solution right. So with that little typo fix there with the denominator being negative 2x plus 4, well, we would always try with a limit like this. With any limit, we'd at least consider direct substitution. So when you do direct substitution, it is a little more complicated than the other ones we've done. You end up with integral from 2 to 2 of t squared minus 4 dt. And then the denominator is a little bit easier. The denominator is just 0. What's going on with the top? Yeah, because anytime the limits match, you're going to get 0. So again, I want to reiterate this for you all just to make sure that it's as clear as I can possibly make it for you. If you are going to end up using L'Hopital's rule in a situation like this sort of thing right here has to be on your paper. Infinity over infinity, or in this case, 0 over 0. That is one of the conditions for L'Hopital's rule to be used. So if you just kind of skip over that and be like, hey, I mentally did it, we're going to have a little issue with kind of your communication as to why you use L'Hopital's rule. So you've got to show that condition there to use it. So if we are going to use L'Hopital's rule, which is where we are headed, I'm going to draw the little arrow with the LH, and we're going to differentiate the numerator as well as the denominator. What is the derivative of the denominator? So that tells us that we're going to be done on this step, right? Not going to get 0 over 0 or infinity over infinity. What did get snuck in on you on the top?
Integral.
Well, yeah, there's an integral up there. And what did you say, Alex?
I said
Integral.
FTC2.
It's FTC2 got snuck in you because if you're going to do the derivative, you'd say d dx of integral from 2 to x of t squared minus 4 dt. That's FTC2 right there. That's the basic definition of FTC2. So the way we handle this, hey guys, the way we handle this is to write limit as x goes to 2. Oops, let's try that again. It would be x squared minus 4. The x gets dropped in, the derivative of x is 1, so it's just that. And now when we apply our limit, what do we get? 0. 0 over negative 2, which is just 0. We leave it alone. You guys solid? Do you have any questions? Okay, number 4 then. Sure. Yeah, I won't take it away. Please check out number 4 if you haven't already done so.
Let me check this thing out.
Is watch what I'm doing, and you feel free, like once I'm done, to let me know how you think I did. Did I do it right? Would I get full credit? Was I close? Was I way off? That sort of thing. Okay? So just watch carefully. Watch carefully. Okay, so you can kind of compare this to what you did. See how it works out.
Hold up.
You didn't write
Hey,
Guys, look, he's done.
he didn't
He's
declare.
gonna make his mistakes on purpose.
He's the teacher, he wants to make sure the right shit.
What do you think? Do I get full credit? If this is an FRQ, do I get full credit?
No. 0.
I get 0. I'm going to remember that next time I grade your test. What's that?
First, if you don't get 100%, you might as well get 0.
Oh,
I've gotten,
man, you hope you don't want me to have that philosophy on your test.
I've gotten a 0 for getting the right answer the wrong way.
Yeah.
And you didn't declare the 0 over 0.
Or it could be.
Because that's the wrong way.
It's like, not separate the variables. Teacher 5, you want to take the mark.
Oh,
The rest.
that's a really good question. There was actually, I should go back and look at that. There was an FRQ with this last year. If we have time, we'll go back and look at that. So I forgot what?
0 over 0.
I forgot to write that down. I just jumped right in and did L'Hopital's rule. The fact that I didn't write the little arrow with the LH is really not that big of a deal. I think that that's a nice communication piece. But what was missing was that. I need to have that condition that allows me to use L'Hopital's rule. Once I've set that condition, once I've met that condition, then I can use it. Yeah, go ahead.
How long does it take you to grade an AP seconds?
Like the whole test?
Because you only... Something's going to happen. They don't keep it together.
Yeah, definitely. Hey, guys, girls. Hey, listen up. Hey, I want to say something. I think a lot of you will get this. I use sports analogies, and if that bothers you, I do apologize, but I think they make sense. There are certain things in sports that are very, very frustrating. For instance, a basketball player at the free throw line shoots a free throw, and they make the free throw, but it doesn't count because their toe touched the free throw line by like a millimeter. Or, how about this? A football play that's a successful football play that scores a touchdown. However, I don't know, the tackle was like 6 inches too far off the line of scrimmage, and so they had an illegal formation. which really had no bearing whatsoever on how the football play transpired, yet the penalty causes the touchdown to not count, right? Or you think about little tiny technicalities, right? That you think, hey, should that really have taken away the points? Should that have taken away the touchdown? Maybe like a gymnast doing their floor routine, which is just like mind-blowingly difficult, and then they step like off of the surface by like a toenail, half-point deduction or whatever, and it's like, that's a legitimate rule. It is, right? But it's frustrating that some little technicality might cost you the win or the game or whatever it would be. So, my point for, hey, listen guys, listen. My point for telling you that is not to distract you. My point is that I think as I walked around, I saw stuff like that going on with this. Little frustrating things that don't necessarily mean you don't get it. It just was little tiny things that would like cost you points. That they shouldn't be costing you points. Let me give you an example. So as you try direct substitution here, did you all get infinity over infinity? Yes. Okay, so we got to have that. I didn't see a problem with that. I think most folks had that. That was okay. Here's where I saw issues. I saw, even a little arrow with the L'Hopital's, but then here's where I saw issues right here. 1 over x over 6x. Okay, so this is going to be one of those things that's going to cost you. The reason is this thing right here disappeared. And maybe it reappeared later or not. It doesn't really matter. It disappeared, which tells me that you did it when you didn't really do it. It's a communication issue for sure. So as that stands right there, that's not good. Even if you wrote this, which is the correct answer, this is a falsehood. 1 over x over 6x does not equal 0. 1 over x over 6x equals 1 over 6x squared. It's the limit that causes the whole thing to have the value of 0. So that's all not good stuff on the communication side. That's going to be one of those little technicalities that's going to cause you to lose points and make it look like you don't know what you're doing when you probably actually do. So what you want to write is this. Limit, as x goes to infinity, of 1 over x over 6x. So we do L'Hopital's rule. And maybe you clean it up a little bit. I think copy.flop is wise here. So limit as x goes to infinity of 1 over 6x squared. And now you can finally say, I think pretty clearly, that the denominator is getting really large. The numerator is held constant at 1. Therefore, the answer here would be 0. That's going to be good presentation. Obviously, we got the right answer. That would not be frustrating. Blake. Put a parentheses around, say again?
Around the 1 over x at the top.
Like this?
Yeah,
I don't think so. I don't think you have to. Okay, well, there you go. It's up there. Mission accomplished.
Technically, it could be 1
It'd
over
be nice to do.
x over 6x.
It's the same answer, but that's the same thing.
It's okay. Are you okay with that? Okay, good deal. All right, so maybe you'll notice, hey guys, maybe you'll notice this down here. There are some lovely, lovely questions designed to help you as you prepare for your quest next week. I would suggest that you use those and use them well. I think that'll help you a lot. Okay, L'Hopital's rule for the moment is done.